Hello. We're ready to look at domains of rational functions. We know what a domain is. That's what values the x's can take on. But what's a rational function? Well, let's think back for a minute to a rational number. If we have a rational number, we know we can put it in the form of p divided by q, where q is not 0 and p and q are integers. So a rational function f might look like p of x divided by q of x, where p of x is a polynomial and q of x is a polynomial, and of course we couldn't let q of x equals 0. So we'll have to make sure q of x is not 0. Well, if we're dealing with fractions and q of x can't be 0, then we have got to think about domains, haven't we? So let's move to a slide and work on the domains here. For g of x equals 3x squared divided by the product of x minus 5 and x plus 6. Well, in factored form, we don't want this factor to be 0 or this one. So it's easy to see that x can't be 5 and x cannot be negative 6, because we'd get 0 if x were 5 for this factor, and 0 times this one would be 0. And of course, if I plug in a negative 6 right here, this factor becomes 0, and I have 0 in the denominator. So now let's just think about this on the number line. Here's our 5, here's our negative 6, and we put empty circles there because we know we can't use those numbers, but we can use anything else. Sometimes either visualizing the number line in your mind or drawing it out helps you convert to interval notation. So we have an interval that starts, not really starts at negative infinity, but it's going toward negative infinity, comes up to negative 6 and doesn't include it. Then we start on the other side of negative 6 without including it and go to 5, jump over 5, and go out to positive infinity. And we can say the union of those three intervals make up the numbers that we can use for our domain of g. This coming back to you now? Okay, what about the domain here? We're not so lucky. It's not factored for us in the denominator like it was a few minutes ago. So let's factor our denominator and see if that helps. So we'll do h of x equals x plus 5 divided by x plus 5, x minus 5, because we're dealing with the difference of squares. This one reduces. Does that affect our domain in any way? No, not really. We have to look at what we can't use in the beginning to get our domain. We may reduce, we may not, but the domain, whatever we couldn't use here, we cannot use no matter what we end up with. So what do we know? X cannot be negative 5, x cannot be 5. So if we're skipping negative 5 and 5, we can draw it on the number line if we'd like. Skip them. Color in every other number because those are the only two numbers that are going to give us trouble. And we're going toward negative infinity on the left until we get to negative 5. So negative infinity to negative 5. Jump over negative 5 and start immediately on the right and go to 5. Jump over 5 and start immediately to the right and go on to infinity. And use either commas or the union symbol to separate your intervals, depending on what your homework program wants you to use. All right, let's find another one. Well, our problem here again would be we can't let 0 get in the denominator. I don't know know how to factor that one, do you? X squared plus 25. That's not the difference of squares. Let's think a minute. We do not want x squared plus 25 to equal 0. We're going to think about this two ways. One is we're going to think about the mother graph, y is x squared, shifted up 25. So we'll pretend this is 25 right here for y. And let's see, this thing turns up because the coefficient of x squared is positive. You know what? X squared plus 25 can never equal 0 because y equals x squared plus 25 is what we have graphed, and y is never 0, is it? It never lands right down here where y is 0. That's one way to think about it. The other way is this. I can use any number I want and square it, and I will either end up with 0 or a positive number, no matter what I square, if I'm picking real numbers. And remember, we're looking at the domain of real numbers here in this section. So this is either 0 or positive, and then I add 25 to it. I can't ever hit 0, can I? I'm always at a positive number, 25 or greater. So that's two ways to look at that. There are no numbers to exclude. So if I'm excluding no numbers, then in interval notation, I'm going toward negative infinity on one side and positive infinity on the other side. Okay, that concludes looking at the domain of rational functions for now, and we'll start looking at how to graph them next time.